Hello, this is the basics of my game tutorial. First of all, we have a start screen, which can be clicked on to select the levels. They're separated into the Fuzzy Logic and Neurals demo and the A-Star Pathfinding demo. First, we have the Fuzzy Neural Network demo. Just click on it to start here. Now, to best showcase this, I'm going to go through it separately, step by step. First of all, I'm going to demonstrate the neural networks, which take in two inputs, player health and enemy health, and have two outputs, attack or to continue patrolling. Now, as I mentioned in the report, I have separate personalities for each tank. I'm first going to demonstrate the neural networks, then demonstrate the fuzzy logic separately, and then both together. Now, just let it start there. So as you can see, you've got first aggression, third aggression, third aggression. If I were to shoot that again, it changes to its patrol state. And if I were to shoot this one, it has gone down to patrol. And if I were to shoot the second most aggressive one, that does not go down to patrol for some time. Now the first aggression will attack no matter what, and as player health goes down, or enemy health goes down, it will change the states. Now if I were to let one of those shoot me, you can see that changes to patrol, and again, if I were to be shot again, the third most aggressive, okay, so now that my health is sufficiently low, all have gone to chase, so if I were to shoot that one again, knock it back to patrol. If I were to shoot this one again, let its health go down, it goes back to patrol, and as you can see, each one has varying states of aggression depending on what the player health is at and its own health is at. Now I'm going to demonstrate the fuzzy logic component of my game. So the fuzzy logic is separated into membership functions, and the degrees of truth are measured via low health, medium health, high health, and low mana. Wait a minute. Healer's mana is set to 0. Oh, sorry, I did not put the healing system on. Okay, now, so let's let that load. You see the healer's mana is currently 25, and in the system I've implemented, it currently regenerates over time. So if we let that tick up a little bit, and as you can see, the next heal amount is represented, and because the healer's my health is high, there is no need to heal for a high amount. And as you might be able to see in the scripts, the mana amount is taken down by the strength of the heal, divided by 2, I think. So if I let my health go down, there's more enemies will attack me. So as you can see, the next heal is quite significant as my health is low. As my health has gone back up again, it is adjusted again. And if I go back down, yeah. If all enemies attack me, yeah. And away again, and the next heal correlates with the healer mana and player health. You can have a go, play around with these values, and that is done via enabling the capsule object, which holds the healer script and the fuzzy game object. The healer script essentially controls the healing that is needed, the mana regeneration, and the start functions. And the fuzzy game object it essentially contains my fuzzy membership functions, which have the upslope, downslope, extend functions, and they also use the fuzzy logic operators, which are these. You will be able to see them if you read the code in the comments. This is what calculates the crisp output values for the amount of healing needed, and this is the actual amount. So as you can see, I have added weightings to each one to make the heals bigger or smaller depending on what the actual fuzzy values evaluate out to. And in terms of the neural network, this is just the standard code that was given to us in the lectorials, and essentially it trains the brain with 50 or so outputs initialized to what they were in the lectorials. This is the method which gives it the input, which would be player health and tank health. In terms of giving the enemies personalities, this is done via the array manager. So these are aggressive to most aggressive, as you'll be able to see. Just some simple stuff in terms of how the game is controlled. I'm using a fairly simple finite state machine to control the behaviors. So it's holding an enum to control patrol state, chase state, attack state. However, some of these aren't really relevant, as I simplified some of their behavior with a neural network as I found it becoming a bit too complicated. So really the only behaviors are patrol and attack and chase depending on the distances. These are just the general field variables that are in it. This assigns the neural network personality array based on the tag system in Unity. For tanks, this is just the general setup state for the tank. These are the waypoints, which are used for the patrolling behaviors of the tanks. This is just general setup stuff. It connects the turret parent-child to the tank object. This is the update, the main game loop within Unity. It's just saying, if it is in any of these states, go to the behaviors needed. This controls the shoot rate for the tanks. This is, if the health is below 0, set the state to dead. And this is the method which feeds in the data to the neural network. And this uses the method from the neural network class to feed in the player health and the current tank health. This returns the current state. This is the tank patrolling. This is generally if it has reached a wonder point change. This is saying that if the distance between the player and the tank is less than 300 and the state of the neural network is chase, attack the player, rotate the turret, and go forward behavior. This is the chase behavior. This is saying that if the distance is less than 200 and the state is chase, again, attack. This is actually, this is saying that if it is near the tank and it is saying evade or patrol behavior, go back to patrolling if the player's health is too high or it is too low. And finally, if the player is less than 300 feet away or 300 float, continue patrolling and don't engage unless it is less than 300 feet away, and again just go forward behavior. This calculates the distance between the player. This calculates the distance between the player and the tank. This gets the player's position, and this calculates the distance between the player and the tank using player transform position. If distances, so this is saying rotate to the target point, rotate the turret, and this is the actual rotate method. This is making the tank go forward, and this is setting the current state to attack. And again, if you're more than 300 feet away, just set it to patrol. And this is out of all of the Boolean statements. It's just saying if it is in range, it will always rotate the turret towards the player. And this is the shoot bullets method, which is actually below. And again, when the player's health is below 0, this is set to true, and this is set to false, sorry. And destroys the game object, i.e. the tank, enemy tank, and B that is set to true. This is the shoot bullet method. This essentially means that elapsed time is reset to 0. But up here, yeah, elapsed time is set to 0 and will be incremented. Sorry, it's an update method. Yeah, sorry, elapsed time keeps going up in accordance with delta time, which essentially means that it limits the enemy's shoot rate to every 3 seconds. So this instantiates the bullet object at the bullet spawn point, which is at the nose of the tank, and will be in accordance with its rotation. This is saying that if the player bullet, because it is using the Unity tag system, anything tagged as bullet comes into contact with it, minus its health. This essentially generates a random point within the map and makes the enemy object go to it. This is just the bottom right hand corner, and this says that the destination position is going to be in this point list at this wonder point plus the random position. However, sometimes the position might be one it's already been at before, or actually the same position the tank is currently on. This method is make sure this doesn't happen using this method. What else? This general bullet class, nothing really, just how fast it goes across the map before it despawns and the amount of damage. However, I have actually set the damage so that isn't really necessary. It's just saying when it comes into contact with something, despawn it, and this is essentially what makes it go across the map. And the start method is destroy the game object after 3 float. Player tank, again, very similar to the enemy tank. Really, the only thing that has changed is that it's not using the neural network again. Health, speed, grabbing the turret child object, getting the health. This just freezes the player once the game has actually ended. Again, vice versa, if it becomes into contact with a thing tagged as bullets, it reduces health by 10. Same for the update dead state in the tank. Yeah, these methods are slightly different, apart from the health, which is the same. This is just really standard Unity code in how you want to have something respond to the mouse being able to rotate around the game object in order to control the tank code. Again, very standard Unity code to actually control something with actual variable speed. Again, this is just to make sure that the value is slightly less for shoot rate on this, just to make sure that you're not spamming too many bullets and not too many game objects appear on the screen. And this again just instantiates the bullet game object very similar to how it was in the enemy objects. Okay, so yeah, I think that's it. Again, I'm gonna do a separate video for the A-star pathfinding